All right, we're going to keep extending on unit circle today. We're going to look at how to tie in sine and cosine to the unit circle, and also given one coordinate on a unit circle, be able to find the other coordinate. Ordered pairs on a unit circle are always in the form of an x, y, because x is your left to right, y is your up and down vertical part to it. And let's let A be the angle measure in either degrees or radians, doesn't matter. On a unit circle then, what that will end up being is that your x coordinate will be the cosine value of whatever the angle is. And your y value will be sine of whatever that angle is. And the reason is, no matter where you are on the unit circle, you can draw a triangle in with whatever the angle is. So let's just say, here's the angle A that we're using. We can form a right triangle from that. Knowing its unit circle, the hypotenuse will always end up being 1. And this is, like we said, a right angle here. So if I want to find where that coordinate is, we know it's going to have a xy value. But we also will know that x and y are equal to something here, because if I want the x value of this, I want to know how far is this side right here. Well, on my right triangle, that ends up being my adjacent side here, because this is hypotenuse and this is my opposite side from my angle here. Well, which trig function uses adjacent and hypotenuse? Well, remember our little SOHCAHTOA saying? That will end up being A and H is cosine. And so this x side of the right triangle right here, if I did cosine of angle A, it would be equal to my adjacent side, which is x, over my hypotenuse, which is 1. Well, if it's over 1, that doesn't really change anything. And so cosine of A will then be equal to your x value. All right. Similar, if I look at sine of that angle, sine uses the opposite and hypotenuse. So if I look at the opposite and hypotenuse on here, the opposite side would be my up and down y value, and my hypotenuse again is 1. And so if I do this one, sine of my angle is opposite over hypotenuse, so it'd be y over 1, or just y. And so when we're doing this here, not only is it an xy value, but it's also your cosine of the angle value and your sine of the angle value. So any ordered pair is always going to be cosine of whatever angle is for your x, sine for your y. So we should be able to find some exact values for these locations on unit circle then. All right, so if I want to know what is sine 30, that would be, because it's sine, that should be my y value on the unit circle when we have 30 degrees. So think back here to previous lessons we looked at unit circle. If I know that's 30, what did that ordered pair come out to be? You could use that little hand trick we talked about, where this is 0, 30, 45, 60, and 90. If we want to find the 31 here, remember you're taking the 30 out and you're figuring out it's going to be square root of what over 2? Well, to the right there's 3 fingers, so the x coordinate would be square root of 3 over 2. There's 1 finger to the right, so that'd be square root of 1 over 2. Square root of 1 over 2 is just the same as 1/2, and so this would be 1/2. And so that should be my ordered pair right there, square root of 3 over 2, 1/2. If I want the sine value of 30, that would be my y value right here. So this should be equal to, either one of these should be equal to 1/2 because it's the y value. Let's go on the calculator just to double check that. So on your calculator, one thing you're going to see is that there are, if you hit the mode button right here next to my second button on the top row there, you have some choices of how you're going to enter in your angle, either radians, or your calculator probably right now is set on degrees because you haven't really used radians before. So if I go back to my main screen and I go sine 30, this should equal 1/2, like we looked at, 0.5, 1/2, yep. If you want to enter it in radians, go back to your mode, and then go down and change this into radians. Now we need to enter the angle in radians, just to show you that it's in radians. Now watch if I do sine 30. It's not doing sine of 30 degrees anymore, it's doing sine of 30 radians, which is something much different. But if I do sine of pi over 6, because pi over 6 is equivalent to 30 degrees, this should again give me 0.5. Okay, because it's equal to 1/2. All right, so then cosine of 30, that's the same triangle we just looked at then. That would be talking about our x value, because cosine's always your x value. So we can see that's our same triangle right here. This should be equal to square root 3/2. All right, so again on the calculator, if you look at this one, I'm going to go back to degrees here. If I enter in cosine 30, I'm going to get this decimal number, which might not mean much to you. But now let me also enter in square root 3/2. So if I do square root of 3, I got to hit over to get outside of that square root, divided by 2. That should enter equal the exact same thing. And you can see that that does equal same thing there. So that's one equivalency as we're going through this unit. Anytime you see this approximation of 0.866 on your calculator, that is the equivalency of the square root 3/2 number there. All right, what about if we did sine of 240 or cosine of that one? Well, where on the unit circle is 240 going to be? Well, let's see, we got 240. That's more than 180. So we know it's not quite to 270 either. So that's going to be in our quadrant 3 over here on our unit circle. And if we did 180 minus 40, that's going to be 60. So this is a 60-degree angle in that third quadrant. All right. So the angle we're looking at right here, that would be our 240 degrees taking us there. All right. So what is sine going to be? If we want to figure that one out, let's figure out what's that ordered pair for right there. We know it's in the third quadrant, so both of these should come out to be negative. What's that going to be? Sine is the opposite over the adjacent. So if I move opposite that angle, that would be that side over the hypotenuse, which is 1. So I know it's going to be the longer side there. Remember in this one that comes out to be square root 3/2. The shorter side, that's half of our hypotenuse of 1, so that would be 1/2. So if we're looking at sine, that's our y value. It's our y value, so it looks like this should come out to be equal to negative square root 3/2. If we want to test it on the calculator, I believe right now I'm in degrees here, so if I hit sine 240, Yeah, so you get the same decimal number sub negative, so it looks like we got it right. That also means the cosine of that same angle should be the x value here, and so this would be equal to negative 1/2. So if you type in cosine of that same one, cosine 240, should get negative 0.5. All right, so that's using the coordinates of sine and cosine to find those, knowing which one's the x and which one's the y. Again, there's our list here. You can see 240 does come out to be what we had there. All right, let's find the exact values for these. So sine of 2 pi over 3. Um, uh, First off, we want to know what that angle maybe would be. 2 pi over 3, if you're not sure, you could convert that to degrees. Remember our conversions, pi over 180. Pi's cancel here. I also know 3 goes into 180 60 times, and so 2 times 60 would be, it's 120 degrees. So where on the unit circle, where would that be? Well, from here to here, that's 90. If I'm minus 90 off of that, I got to go another 30 here. So there would be, that's 120 now. So if that little bit was 30, that means remaining here is 60 degrees. So what do we know there? What's the x and y values going to be? Well, if you're not good at remembering these, that's fine. But if you know 60 degrees, that would be 1. That means the short side should be half that. That's a half, and then using our triangles, that's square root 3 over 2. So it looks like the ordered pair here then should be your x value, and it would be negative because it's in the second quadrant, and this should be positive square root 3 over 2. If we're looking at sine, that's our y value. And again, sine, think opposite over hypotenuse. Opposite, that's the y value. So that would mean this should equal, right here, square root 3 over 2. You can test that by going in your calculator. Now again, you got to make sure you change to radians here if you're going to do this one. Sine of 2 pi over 3. And there's our same decimal approximation of square root 3 over 2. All right, let's try another one here. Cosine 3 pi over 4. So 3 pi over 4, where's that on our unit circle? This one I'm not going to draw. Let's go back to here. 3 pi over 4, we can see is the same as 135 degrees, and you could get that doing our conversion. That's in the second quadrant here. That also means if we have 135 degrees there, if you do 180 minus 35, that tells us this is 45 degrees. In a 45, 45, 90 triangle where the hypotenuse is 1, both of these are going to be square root 2 over 2. And we can see there's our ordered pair then with being in the second quadrant, that first one's negative. So if we're looking at cosine, that's our x value. X value in this quadrant is negative square root 2 over 2. And so this should equal negative square root 2 over 2. And that's what they mean about exact value. They don't want the decimal approximation, they want that exact value. Testing it on calculator, if you do cosine of 3 pi over 4 here, we get this answer. And if you type in square root 2 over 2, you can see that they are exact. They are in fact the same. Make sure you hit over here to get out that square root 2 over 2. same amount. You can just see it's negative instead of positive on that second one, but same amount. So what that also means is this is another equivalency that comes up quite a bit. If you remember that, anytime you get this 0.707, that's an approximation for square root 2 over 2. All right, once you pause the video, see if you can find the exact value for C and D now. All right, so let's see what you got. You should have came up with -1 and a +1. This 3 pi over 2 is the same as 270 degrees on a unit circle. That puts us right there. So what is the ordered pair for that? 0, -1. Sine value is our y, so that would be our y value of -1. Should also give you the same thing if you did it on the calculator. Cosine 0, 0 is right here. What's that ordered pair? 1, 0. And then cosines are x value. And so if you got x value here, that's going to be the first one here. That would be 1. All right. So that's finding exact values with unit circle. Also, because we use unit circle, any of the points on the circle should satisfy the equation of the circle, which is again x squared plus y squared equals 1 squared or 1. So anytime you have an ordered pair, for example, 30 degrees here, we know gives you this ordered pair on the unit circle, it should satisfy this equation, meaning if I put in square root 3 over 2 for x, and 1/2 for y, that left side should in fact end up being 1 there. And just to do that, I'll show you here. Let's square both of those. So if I took and squared both top and bottom number here, bottom 2 squared is 4. If I square the top, square root of 3 squared is just 3. If I square the second one, 1 squared is 1. 2 squared is 4. If I add up 3/4 and 1/4, I get 4/4, which is the same as 1. You can see that it does in fact work. So any point on a unit circle should satisfy that. So if you get problems like this that say use the equation of the unit circle to find the other coordinate of this point, we should be able to do it. So they're saying the x coordinate is 4/5. And this is a point in the fourth quadrant. What's the y value? So we know this ordered pair is 4/5 something. What's that something? What's the y value? Well, let's do what we just did. Let's put this in for our x value and then figure out what the y value would be. So we got 4/5 squared plus our y value squared should equal 1. If I square that, that's 4 squared is 16, 5 squared is 25. Now I got to subtract here. If I'm going to subtract that from 1, it's probably easier to think of 1 instead of 1 as 25 over 25. Let's get a common denominator there. So if I subtract 16 25ths from 25 25ths, I got y squared equal now to 9 over 25. Last thing now, I got a square root. And so if I square root this, y is equal to plus or minus the square root of 9 25ths, which means y is equal to plus or minus 3/5. All right, so which one should I select here? And it does make a difference because this says we are in the fourth quadrant. Remember, anything in the fourth quadrant, that's down here. That means our x value is positive, our y value comes out negative. And if we're finding that y value here, that means we do in fact want to use the y one here. So here we would know that y is going to end up being negative 3/5 because it's fourth quadrant. So we want to use the negative one here, negative 3/5. That would be our ordered pair there. All right, let's try another one of these. Use this again to solve. This one's in the third quadrant, find the x. Our y is negative 4/9. So we're going to take that value, plug it in for the y, solve for the x. Okay, so if I square that, remember squaring means you're multiplying two the same thing. So if I multiply two negative numbers together here, this should come out to be positive. So 4 times 4, 4 squared would be 16. 9 times 9 is 81, or 9 squared would be 81, equals 1. I'm going to, again, change this. Let's get a common denominator. Let's think of this as 81 over 81. So now it's minus 16 over 81. So now we got x squared being equal to, if you subtract that, that's going to be 71 minus 6 is, I'm going to get calculator to help me on this one. Let's see, 81 minus 16 gives me 65. So this is 65 over 81. Okay, next up, let's square root now to find x. So x would be plus or minus the square root of 65 over 81. Now that bottom number we can definitely square root, which that would just give us 9. The top number is 6 squared of 65 is not a perfect square there. And I don't think there is any perfect squares that divide into there, because 13 and 5 are the two numbers that divide in, and neither of those are perfect squares. So we'll just leave this as square root 65 then. So then, which one do we want to use, positive or negative one? We're third quadrant here. Third quadrant would mean anything in the third quadrant is going to be a negative for both, so we want to use negative square root of 65 over 9. So we'd use the negative one because it's third quadrant. All right, let's have you guys try one out here, see if you can do this one. So pause the video, try it, and see if you can find this y value. All right, let's check out how you did. So if you put that square root of 3 over 4 in for x, square it, you're going to get 3 over 16. I minus that, you get 13 over 16 square root, you get plus or minus that. Bottom you can simplify to 4 there. Which one do we want to use, positive or negative? Well, if we're in second quadrant, which is here, the y value is going to be positive, so we want to use the positive one. So the answer should be positive square root of 13 over 4.